Next our topic is area of a triangle. So here we have vertices, 3 vertices, x1, y1, x2, y2, x3, y3. That is in form of coordinates we have the vertices. You might have learnt in your junior classes area of triangle in your coordinate system, Cartesian system I mean. That is half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So this was the formula what you have learnt in your lower class, junior class. So in determinant form you write like this: determinant equal to half, this half, okay, x1 y1 1, x2 y2 1, x3 y3 1. Nothing, as usual. How do you find the value for your determinant? Same method you will be applying over here. Area is a positive quantity. Even though after solving you get a negative value, suppose you get negative 3 or something, but negative is there, so it's nothing. You have to write in a the absolute value of that. That is, if you get negative 3, your answer will be 3 square unit. Second point, if area is given, use both positive and negative values of determinant for calculation. This, while solving the problem, I'll explain you more clearly. Area of triangle formed by 3 collinear points is 0. This you have learnt in your junior class. That is, if there are 3 collinear points, means the points lying on the same line. If this is your line, here we have 3 points. If it is lying on this, you say this collinear points. We know that according to definition of triangle, that when you join 3 non-collinear points, you get a triangle. So if 3 points are collinear, that means it's not a triangle. Got it? It is a line. So depending on that, we have exercise 4.3. First problem, find area of triangle with vertices at the point given. So these are the given points: negative 2, negative 1, 3, 2, negative 1, negative 8. So we write the determinant for area of triangle: half x1 y1 1, x2 y2 1, x3 y3 1. Substitute those values, the coordinates given. When we substitute, now nothing, use your usual determinant formula. See that you continuously keep that half. So let us start solving. So negative 2 into don't forget half, negative 2 into 2 into 1 minus 8 into 1. Next, minus 3 into 1 minus 1 into 1 plus 1 into 3 into negative 8 minus 1 into 2. Okay, next step. So we have half, negative 2 into 2 minus plus 2 plus 8. Here minus becomes plus. 3 into 1, 3 minus, and this minus plus again. So 1 into 1, 1 plus 1. 3 into minus 8 is minus 24. Minus 1 into 2 is minus 2. So minus plus, so plus 2. Half minus 2 into 10 plus 3 into 4 plus negative 24 plus 2 is negative 22. Next, half into minus 20 plus 12 minus 22. So when we solve, what we get? Minus 20 minus 22 minus 42 plus 12 is nothing, minus 30. So half into minus 30 is minus 15. Since area is positive quantity, according to the property, we always take the absolute value of the determinant. So the absolute value of the determinant is 15 square unit. Second problem. Show that points, here we have 3 points, A, B plus C, B, C plus A, C, A plus B are collinear. Collinear means all these A, B, C lie on the same line. Okay, so we have one formula, like when you find the area of the triangle, you'll be getting is at 0. So let's start. So here the given vertices we have written area of triangle in the determinant form. We substitute x1 y1, x2 y2, x3 y3 in the determinant. So time being I will take it as a determinant only, not as 0. Okay. So we know that area of triangle formed by 3 collinear points is 0. Let's see how it is, whether we are getting 0. So half A into C plus A into 1, that is C plus A, minus A plus B into 1, that is A plus B. Next, B plus C into B into 1 B minus C into 1 C, plus 1 into B into A plus B minus C into C plus A. So here we have written. Next, half. We'll solve inside the bracket first. So C plus A minus B. Then minus C. So C minus B minus A plus B, A plus B, A minus B form it is. Algebraic identity A plus B, A minus B is nothing, A square minus B square. Here we have B plus C, B minus C, that is B square minus C square, plus. So here we solve this, 1 into is the same thing. So B into A is AB plus B square, minus C into C is minus C square, minus C into A is minus AC. We solve this also, AC minus AB. Given minus goes inside the bracket, minus B square minus plus C square, plus AB plus B square minus C square minus AC. So AC we have here and here. So AC minus AC cancel. Minus AB plus AB. We don't have another other ABs. Minus B square plus B square plus C square minus C square. So what? Nothing is left. 0. So half into 0 is 0. So we know that area of triangle formed by 3 collinear points is 0. So hence A, B, C are collinear points. Minor and cofactors. Let's start. Minor of an element ij. Any element ij of a determinant, this whole determinant. Okay, is the determinant obtained by deleting the ith row. By which determinant? A determinant is obtained by deleting ith row and jth column. Ith row and jth column in which the element aij lies. So what is remaining? A22, A23, A32. So this determinant we find. So that is your minor of A11. I'll repeat once again. Minor of an element aij. So I take minor of element A11 of the determinant. This determinant is the determinant obtained. A determinant is obtained by deleting ith row, here first row, and jth column. So jth first column. So using this we obtain a determinant, that is A22, A33 minus A32, A23. When we use this apply on numerical problems, it will be more easier. Likewise, we'll go for A23 will go for. So when we go for A23, so ith column, that is second row, you have to delete, and jth row, that is third column, you have to delete. So A11 into A32 minus A32 into A12. This is the way you find the minor of a particular element in the determinant. Cofactor. Cofactor is nothing. Minus 1 I plus j m I g. To find the value of determinant, taking the sum of the product of the elements of any row. This row I am taking, so elements. So sum of the product of what? The product of element with their corresponding cofactors. So corresponding cofactor of A21 is capital A21. So A21 into A21 plus sum, right, plus A22 into A22 plus A23 into A23. Corresponding means it's nothing. Which element you are taking, that element's cofactor. That product you are taking. Okay, so when you sum up all, you'll get determinant value. In a simple way, here it's nothing actually. You have expanded along the second row and found the value. Let's learn how to find the minor of element 6. So here we have an example. Find the minor of element 6. Where we have element 6 lies in second row, third column. So M23 we are supposed to find. So 6 lies in second row, third column. So its minor is M23. So when it is M23, second row and third column, we delete. And 1 into 8 minus 7 into 2. So 1 into 8 is 8 minus 7 into 2 is 14. So 8 minus 14, that is negative 6. So we got the minor of M23 is negative 6. Fine, we'll go for cofactor here itself. Okay, let's see. So A23. So A23 means minus 1 to the power 2 plus 3, 5. 5 into M23. What is M23? Negative 6. So what is negative 6? So minus 1 to the power 5 is minus 1. So minus 1 into minus 6 is 6. So our cofactor will be 6. Clear? Okay, next find minors and cofactors of all the elements of the determinant. 1 minus 2, 4, 3. So let's start. Minor of element, minor as well as cofactor we are supposed to find. So A11, what is a A11? 1. So minor of A11 is A11 is 1. So minor of A1 is, before that delete first row, first column. So 3. So minor of A11 is 3. Next, negative 2. That is minor of A12. We delete this row, this column. So minor of A12 is 4. Here we got 4. Next. Minor of A21. Delete row and column. So negative 2. Minor of M22. So second row, second column delete, we have 1. So we are done with minor. Now cofactors. Use the minor and change the sign. So here we have minor of A11. Minor of A11 is 3. So we know that cofactor of A11 equal to minus 1 to the power 1 plus 1. So M11. So we solve it. So we get this positive 1 into 3. So that is 3. Next, A12 equal to minus 1 to the power 1 plus 2 M12. What is the M2 value? 4. So minus 1 cube into 4, that is minus 4. The reason is this will be negative. Next, A21 minus 1, 2 plus 1. Remember I plus j, same thing it is. I is 2 and j is 1. M21 negative 1 cube into negative 2. So this will be negative. So negative negative became positive equal to 2. A22 equal to minus 1 to the power 2 plus 2 M22. So 2 plus 2, 4, even. So when we solve, we'll get positive 1. So positive 1 into 1, we get 1. So here we find minor as well as cofactor of all the elements of the determinant. See, this is sort of important, okay? This sort of problem, when it comes, you might get confused. So see that you do it a very clear way. Let's see. So here again they are asking you to find minors and cofactors. Okay, here you'll be getting formulas actually. First we'll go for minor of A11. Minor of A11 is A22 A33 minus A32 A23. If you want, you can skip this part. Next, minor of A21. Find minors and cofactors of the element A11, A21. So here in specific they have asked the minors of two elements, that is A11 and A21. So first we'll go for A11, we'll find the minor and then the cofactor. So A11, so minor of A11, that is M11, is A22 A33 minus A32 A23. If you want, you can skip this part. That's all, because there is no value, so you write as it is. Next, cofactor. Cofactor, this whole thing will be using of the minor, okay. That is minus 1 to the power 1 plus 1, M11. So since this will be positive, so we write A22 A33 minus A23 A32. Next, A21, minor of A21. So M21 A12 A33 minus A32 A13. This is a minor. So can anyone tell me what will be the cofactor of A21? Since it is odd, our cofactor will be negative minor of A21. So, but we'll solve it, okay. So minus 1 to the power 2 plus 1, so we'll get negative 1. M21 is A12 A33 minus A13 A32. So when you put the negative inside this, what will happen? You get negative A12 A33 minus, it will become plus, and A13 A32. So here we got it. Exercise 4.4, write minors and cofactors of the following determinants. I guess it's quite simple. We'll just simply we'll go through it, okay. So first problem, first sub question, 2 minus 4 0 3. So minor of M11. Minor of M11 is, we delete this row and this column, so 3. Next, minor of M12. That is M12 is, delete this row, this column, 0. Next, M21. M21, this row, this column, deleted, so you get negative 4. Negative 4. Minor of A22. That is M22. So this row, this column goes, remaining is 2. So you got the minor of all the elements. Next, cofactors. So cofactor of A11 is positive minor, right? So positive of the minor, that is plus M11. So 3. Next, cofactor of A12. So minus M12. So minus M12, minus 1 into 0. So 0. Cofactor of A21. Cofactor of A21 means minus M21. So minus 1 into negative 4, minus positive. So 4. A22. Again we have positive minor, that is 1 into M22. So M22 is 2, 1 into 2 is 2. So here we got minor as well as cofactors. For order 3 by 3, third question. Using cofactors of elements of second row, evaluate. Cofactors of second row, we have to evaluate what? Determinant you have to evaluate, that is you have to find the determinant using cofactors of elements of second row. So you write the given first, then cofactors of elements of second row. Determinant equal to A21 plus A22 A23 A23. So let's see. First we'll find the cofactor of A21. So A21 is 2, so cofactor of A21 equal to, since you know the base, that is 21 is odd, so a minor will be writing minus M21, that is minus 1 into M21. So don't get confused why I am writing this directly negative. You can write directly, no problem. So minus 1 into M21 equal to minus 1, 3 into 3 minus 2 into 8, 9 minus 16. So 9 minus 16 is negative 7. So negative 7 into negative, that is positive 7. A22. So how do you go for A22? A22, this is A22. A22 means positive minor. So plus M2 it is. So 5 into 3, 15. Minus 1 into 8 is 8. So 15 minus 8 is 7. A23. We'll go for A23. So cofactor equal to, since it's odd, so negative minor, equal to 5 into 2, 10, 1 into 3, 3. So minus 10 minus 3, that is 10 minus 3 is 7, and minus, so minus 7. So when you substitute value, A21 is 2. Cofactor of A21 is 7. Plus A22 is 0 into 7. So that is 0. Plus A23 into cofactor of A23 is negative 7. So 1 into negative 7. So we get 14 minus 7. 14 minus 7 is 7. So this type of questions are important. Next is using cofactors of element of third column, we have to evaluate the determinant. See, in the previous case we had some numerical values. In this case we have variables. So when variables come, it's obvious you have to be a bit careful while solving. So let's start. So this is our given. So cofactors of elements of third column. Third column. Okay. So A13 plus A23 plus A33. So using this we'll be finding the determinant. So A13 equal to YZ. So cofactor of that is Here we have yz. Okay, 1 3, that is positive minor. So 1 into z is z minus y. So we have z minus y. Next, a 2 3 is z x. Cofactor of a 2 3, 1 into z minus 1 into x, that is before that 2 3, since odd, so a minor is negative, so cofactor of a 2 3 is negative m 2 3, so minus z minus x. So I can write this, next step will be minus z plus x, so this is equivalent to x minus z, so I wrote x minus z. Next, a 3 3 equal to xy, cofactor of a 3 3 equal to positive m 3 3 equal to 1 into y minus 1 into x, that is y minus x. Oh no, വെച്ചിട്ട് പോമാ അമ്മ കൊടുത്തു വേണ്ട വേണ്ട ഉള്ളിൽ വന്ന ക്ലാസ് എടുക്കുന്നുണ്ട്, പിന്നെ വരാ. Let's start substituting the values. Determinant a13 into cofactor of 1 3. So 1 3 is yz, cofactor is z minus y. Next, plus zx into x minus z plus xy into y minus x. Okay, now when you see this, I guess you're totally confused. Don't get confused. When such thing comes, see, mainly you have to find the factor. Now it's not in a factor form, so you have to do it. Substitute all what the elements and the cofactors, and we got this. Multiply yz into z, yz square minus y square z, zx into x is x square z minus zx into minus z is minus xz square. Just I have written in alphabetic order, it's up to you, no problem. But when you're following an order, see that it's when next time you encounter such terms, that order should be as it is. Plus xy into y, that is xy square, xy into minus x is minus x square y. Here, now what we are supposed to do, you have to write in the factors form. When such question comes, at the end you have to write in a factors form. Okay, so either you can write z minus y or x minus z, y minus x. Here I prefer to take z minus y. So again, whatever I have multiplied and written over here, I write in its original form, that is yz, z minus y. Now, but here in this case, I have to do some arrangement so that I get z minus y in the bracket. So here I have zx square, which I can take so that I can get z minus y. So here, can I take this? Here I can get x square as common and z minus y also I can use. Now what is remaining? X z square plus x y square. So this also, when I do it, same I'll be getting it. Let's see how we get it. When you don't know anything, just give a start. Sometimes you may reach a conclusion to an answer. Don't leave it. Try to do something. So next, here I have written in the original form yz, z minus y plus x square is taken common. Within bracket I have z minus y. Next step, I take minus x common. When I take minus x common, bracket, what is remaining? Z square. This plus will become minus. Why? Because I have taken minus in common. So since x is also taken common, remaining is y square. Next step, as it is, here no change, but here I can make some changes. Z square minus y square. What is z square minus y square? Your junior class algebraic identity. That is, a square minus b square is a plus b, a minus b. Z minus y, z plus y. Next. So don't you think you have something in common? Z minus y, z minus y, z minus y common. So I take z minus y common. Now what is remaining? Yz plus x square minus x into z plus y. Just check. Yes. See, when you take over here, don't forget the z plus y, because that we have not taken in common in this step. Okay. Only we have taken what common? Z minus y. So what is remaining here in this case? Minus x, z plus y. Next. Now again you have to do some arrangement in this case. So that here we already have z minus y. So what do we prefer next? Z minus y is there. Okay. So something else we can do. So see, yz is there. Then I'll take minus xy. Okay, so yz minus xy, x square minus xz. Proceed. Here can I take y common? Yes. So when I take y common, what do I get is z minus x plus, here I take x common, so within bracket I have x minus z. See, but here some, either you make this, you arrange this one, or you arrange this one. You write in z minus x form or x minus z form. But in my case, what did I do? I just arranged this one. Okay, what did I do is, I made z minus z plus x, and I took out minus out. So what happened? Z minus x. Okay, so when this minus came out, it became minus x. This plus x became minus x. So within bracket I have z minus x. So here again I can take z minus x common. I took. So what is remaining? Y minus x. So here I got the factors.